Hi, I'm Kendra Little from Redgate's Evangelist team. In this video, I'm going to give you a quick overview of the two methods that customers like to use to build databases with SQL Change Automation when there are cross-database dependencies between those databases. So what we're going to do is we're going to talk about why do you have to do anything at all? Why are cross-database dependencies tricky? Then we'll step through just an overview of those two different solutions. I'm not doing demos to keep things speedy. I'm just giving an overview, and then we'll do a super quick recap. So first up, what is up with cross-database dependencies? Well, here's an example. Let's say I have two databases. One of them I've named CDO1, and the other database I've named CDO2. And I have created a view in CDO2 that refers to a table in CDO1. My view has a dependency on that table over there in CDO1. Now, when I use SQL Change Automation to do a build of the CDO2 database, what I'm doing is I'm making sure that all the code I have checked into source is valid. And SQL Change Automation, what it's going to do is actually take all my code in source and execute it and make sure it can execute successfully. Now, I think this is awesome because as a production DBA, more than once I've been handed code to deploy that didn't actually compile, right? So I'm a huge fan of making sure that the code in our database is valid. And of course, things can happen over time, right? We might have created this view in CDO2 like a year ago, right? And maybe a year ago, this table existed in CDO1, but hey, what if last week somebody renamed that table in CDO1, right? What if something changed underneath my dependency and that's not actually valid anymore? Well, I think it's great that we test that and make sure as we build and release our code that things are still valid. So the enforcement here of making sure that that table, cdo1.dbo.foo exists, that actually comes from SQL Server. When you create a view, SQL Server says, hey, I've got to go validate that that thing over there exists. And what we're doing in the build as part of the build is actually creating view and making sure that it creates successfully. So if I run a build against that CDO2 database, if I run that build against a SQL Server instance where the database CDO1, either it doesn't exist or it doesn't contain that table, when inside my build, when it tries to create that view, SQL Server is going to actually give the warnings you see on the screen here. And SQL Server is going to say, that is an invalid object. I failed to create that view. And then the build is going to say, hey, I couldn't create these things successfully. This is a problem. If I want to build the CDO2 database successfully, I need to make sure that we can validate that those dependencies are there. But of course, in the real world, this can get tricky because I could put circular dependencies in place. I could have database CDO1 that is dependent upon objects in CDO2, and I could have database CDO2 that's dependent on objects in CDO1. So if I was attempting to just build both of these databases, if I thought, okay, in order to build database CDO2, what I'm going to do is I'm going to build database CDO1 first. Well, in this case, if I have a circular dependency, I can't just build CDO1 first, right? So when we're thinking about how we want to solve this problem in our builds, even if I don't have a circular dependency today, if there is any chance that I might have one in the future, I probably want to set my build up so that it's not just going to start failing if I'm not building things in a really precise order. When I'm setting up a build, I want it to be as robust as possible in the future, if it at all is possible that something like this might exist. Now, you might be thinking, this is weird because, I have a feeling that I can create some objects in SQL Server and that it doesn't check if they exist. If you have that feeling, well, you're right. SQL Server actually has a feature called Deferred Name Resolution that makes this whole issue a little confusing. But Deferred Name Resolution, it doesn't work for all objects. It's really designed for objects like stored procedures. And it's for a good reason. In a stored procedure, I might reference an object that doesn't exist when that stored procedure is created naturally because maybe that stored procedure is called by another procedure. And maybe the outer procedure dynamically creates that object before it calls the inner procedure, right? Et cetera, et cetera. So it's actually sort of normal for objects like stored procedures to potentially, reference objects that don't exist when the stored procedure is created. So for those objects, they have deferred name resolution. And you can create that stored procedure and it'll say, oh, I will allow you to create this. I'm not going to actually go and check that the tables and things you're referring to, I'm not actually going to go and check that they exist until you actually run the stored procedure. This is not true for things like views and inline functions. So for views and inline functions, when we create them, yes, those objects absolutely do have to exist or it is no longer valid SQL. So it's items like views or inline functions that you're going to notice causing problems with dependencies in the build because those objects must have the dependencies in place in order to be created. All right, so how do we make sure that our builds can succeed and that our builds are robust? Well, like I said, there's two solutions that folks tend to like for this. Solution one is building with a dynamic database name. And as your build instance, you're going to build against an instance where you've already got a set of all the databases in the dependency chain. Now, what does it mean to build with a dynamic database name? What I've got here is a screenshot of the SQL Change Automation extension. This screenshot is taken from Azure DevOps, but we've got extensions for a couple major orchestrators. You can also use PowerShell to deploy this too. So, the way I have this in the screenshot, you could do this with PowerShell too. I have left the database name blank. So I'm telling SQL Server, hey, I want to build over against this specific instance. You could still do that, right? I can specify the SQL Server instance name if I want to use a specific SQL Server instance and not use local.db. But to say I want you to dynamically create the build database, I just leave the database name blank. And the instance that I'm building against, right, I've specified, hey, I want to build against this specific instance. On that instance, I want to always have in place copies of the database that are involved in the dependency. And you can get them there however you like. A popular way to get them there is to just restore a copy of the database. Because when you restore a database with SQL Server, it's not the same. It doesn't recreate all the objects. It's just restoring a backup and everything that exists, whether it's valid code or invalid, right? It just restores everything, right? So it's not checking any dependencies at all in a restore. So we make sure that the databases are built, and all involved in these dependencies, we restore them and we restore them with the same names they have in production, right? Because unless we've done something like use synonyms to help make our cross-database dependencies either, the database names are hard-coded into those cross-database dependencies. So as long as I'm keeping these databases here, when my build starts up, my build says, oh, okay, we're not going to touch these. We are building with a dynamic name. So these databases are ready before our build begins. And what our build does, because I left that database name blank, it creates a new database to build in, and it gives it a dynamic name. Now, the name will always begin with DLM automation and then have a GUID-like thing after it to make it unique. So if, say, I'm running a build for CDO2 and I left the database name blank, it will just generate this name. So that'll just sit next to the other databases. And any dependencies this has on CDO1 or CDO3, it will be able to validate because, hey, look, there's CDO1 with all of its normal objects in it. There's CDO3 with all of its normal objects in it. And that can be very useful. And it's very, very handy to do it this way because let's say I want to support running multiple builds on this same SQL Server instance. If another build starts up for CDO3, well, as long as I've configured the build for CDO3 and I've left that database name blank, it's going to just create a new dynamically named database for CDO3. It can coexist and it can satisfy any dependencies it has to with the databases on that instance. So the dynamic name is very, very useful. And it means that I am not modifying anything in that family of databases that already exists on the instance. We can run multiple builds at the same time. When you're running a build and you're saying, I've left the database name blank, you name it for me, when that build completes, the database that was created is automatically dropped and cleaned up. You'll get messages of success or failure in the build itself, but it automatically cleans up after itself, which is quite nice. But of course, it doesn't clean up those databases that we restored and kept on the instance. Now, there is a gotcha with this one. One of the things you'll want to check your code for if you're building with a dynamic name is look in your code and see if you have code that uses three-part naming to reference code in the current database. So for instance, if I have a view in here that's selecting from a table, and in the view, the table name is coded as cdo2.dbo, and then the table name, or whatever the schema name is, right? But I specified it, the view is in the cdo2 database, and I put cdo2 in the table name as well. Well, it's not going to look at the right place to validate, hey, do I have the right columns from this table selected, et cetera, et cetera. It's going to go look at the database actually named cdo2. It is generally a good practice to only use three-part naming when you have to, right? In all of your code, you only want to actually put the database into the SQL statement if it's in a different database, and you absolutely have to specify it, because specifying the name just limits your flexibility, right? And in a lot of cases, a lot of people do like to, in different environments, be able to have different copies of the same database with different names, and using two-part naming helps with that too. So this is a gotcha you've got to look out for if you are building with a dynamic database name. Another thing you have to think about, and this isn't hard, it's just a step, is that we do want to keep the schema for these build databases current. We are using, though, if we're doing DevOps and we're using an automated deployment pipeline, that is totally something we can do with automation. So you just need to figure out at what point do we want to, and if we are deploying to production, at what point for a deployment do we also want to update the schema on the databases that we're using for build? So it can make sense to do this when a change is going either into the pre-production or a production environment, depending on your process. You just want your pipeline to make sure that these build databases are not getting out of sync with reality, and that when you are validating your dependencies, you're validating against the right version of the schema. So quick recap. Why in this solution did we say build with a dynamic name? You might be wondering, well, why can't I, if I'm building cdo2, why can't I just build cdo2 on this instance? Well, when we run a build against a database, if I were to run a build against the database cdo2, the very first step in the build is it cleans out that database, right? Because I want to validate the code from source in that database. So if I run a build against cdo2 itself and my build fails, well, I've left cdo2 in a state that isn't useful for future builds anymore, and I need to reset it. And if the way I'm maintaining these databases is to do something like a traditional database restore, well, that can take a long time, depending on the size of my database and whether I want to mask any data after the restore. That could actually take a very long time. And while that's happening, if I want to build either cdo2 again, or if I want to build something else that is dependent on it, then I'm stuck, right? So if we are using a method to maintain these dependency databases that is slow, we really want to build with a dynamic name, because we don't want to have to reset them very often, or we only want to have to reset them if we absolutely have to. We'd rather keep them updated another way. So that is the first option for putting those dependencies in place. The second option for this says, okay, we're going to find a fast way to put those dependencies in place as the build itself runs. We don't want to have to worry about a long restore process or having to reset these, and we want the build to be able to dynamically do this anytime it runs. Redgate's SQL Provision product can help with this, because SQL Provision allows you to automate some regular processes. Like we could say, whatever interval we want, maybe every night we're going to take a production backup and have it create an image of that backup again on our clone server. And maybe we're even going to mask data on that image, so that now this image is useful for development. After I've created that image, I can create clone databases off that image really, really fast. so fast that I can actually do this dynamically during a build to say, hey, I want to throw these dependencies in place really, really fast. And this is very nice because if we do want to hard code the database name in the build and say, yeah, for CDO2, I actually want to build it with the database name CDO2, we can do that with this model, and that's very, very nice. Now, one quick implementation note, when you do this in a build, when you specify a database name, the build expects that database already exists. It's not going to create a database named CDO2 for me. If I say CDO2, at the time the build begins, a database named CDO2 needs to be in place. Now, it doesn't need to have anything in it if you don't want to. It just needs to have a database on this instance named CDO2 because I've hard-coded the name. So in my example build, what I would do in this example is I've already got, a regular, maybe nightly process creating those images, right? So what I would have my build do is use either built-in extensions that we've provided for major orchestrators like Azure DevOps or Octopus Deploy, or I would use the PowerShell extensions. And I would say the first step I want to do in my build is actually create clones of all the databases that are involved in these dependencies, and I want to throw them on the SQL Server instance where I'm doing the build, right? And clones create really quickly. So this can be done, this isn't going to slow down my build a ton of time. I would not want to wait for a long database restore to happen to do this, but this is where the magic of cloning comes into place. There's also a flag that says if the database already exists, replace it when you're creating a clone. So even if, a build has just run, I can say, yeah, I want a new set of these dependencies because, hey, somebody may have just been building in one of these databases. And then voila, the build proceeds. If I'm building in CDO2, even if I've just created a clone for it, the first step in the build, it's going to clean out that database and then validate the code inside the database. This is awfully nice to be able to build with the database name itself, because what if I do have code in there that uses 3-part naming for the database itself? I don't have to worry about whether that's there or not. It is everything's using the same name that it has in production. So everything's going to validate as I expect, or if it doesn't validate as I expect, I really want to know about it because that's clearly indicating a problem in my code. No need to drop the databases after this happens because, as we said, we can specify in the clone commands whether we want it to be able to recreate those databases when a clone runs. Now, the way I have set up this example, only one build can run against this SQL Server instance at a time. I don't think that's too bad a thing, though, because in terms of timing, the clone creation step is fast enough that I don't mind a build queuing up behind it. But if you would prefer to enable multiple builds to run against this SQL Server instance at once, you could still say, hey, we want to build with a dynamic database name, right? And then each build that you're running builds in its own instance. It isn't interfering with the dependent databases, and multiple builds could run together if you do want to do that. So you absolutely have the choice with the provision model as to whether or not you want to have one build running per SQL Server instance. Of course, you could have multiple build servers, each with their own SQL Server instance, and parallelize that way. Or you could say, hey, we all actually want to build everything against this single SQL Server instance and use dynamic names so that we can have many concurrent builds running at the same time. So a quick recap of what we've covered. When it comes to build dependencies, there are really two options that we find that folks like. Either set up an instance and use traditional restore to get your dependent databases in place and build with a dynamic name on that instance. This isn't hard to do. You want to make sure that you do have a step in that build pipeline that's going to say, hey, we are going to keep, we're not going to let the schema on these databases drift. When a deployment's heading to production, we are going to update them on the build server as well. But hey, you're automating things in a pipeline. This can be part of your pipeline. That in itself is not a problem. We just need to remember to do it. Or option 2, we can say we want to, every time the build runs, be cloning our dependencies into place using recent, probably masked data that we've created images from our production environment. And you can do that with SQL provision if you choose. Thanks so much for joining me for this video about cross-database dependencies and builds. I'm Kendra Little from Redgate's Evangelist team, and I'll see you in another video soon. Bye, folks.